So there should be a proper algorithm that removes the instability. Okay, there are actually many algorithms, but this Gale and Shapley in the year 1960s, I think, yes, 1962, they first proposed a correct algorithm which solves this problem. Okay, and they gives a pair of, I mean, at the end of their algorithm, you get a bucket of pairs. Okay, it's a perfect match and it's a stable match. That means you cannot find it's a blocking pair in that match. Okay. So that's the whole purpose of a stable match. Now, where is greedy coming into the picture? Where is greedy coming into the picture? Okay, that you have to study the Gale-Shapley algorithm. You go through the book. It's a very simple pseudocode. Okay, so what can be a question that where is the greedy nature in the Gale-Shapley algorithm? Where is the greedy choice basically? That is one important question. Okay. So once that is done, then there is certain uh, questions like how much given I mean a bipartite graph of size n cross n. I'm saying this n cross n because assuming left side has n elements, right side has n elements. Then what is the I mean what is the amount of time that it takes to solve the problem? Okay, so that you have to analyze properly. Remember that if you look into the pseudocode that is in the book, or it can be obtained from the Google, there may be requirement of some data structure. For example, I said that there is a vector. Okay, there is a vector of ordering of the students for each teacher, and there are n such teachers. So we need n vectors. Okay, so these n vectors can be stored separately, or they can be stored in a compact manner in a matrix. So I need at least two n cross n matrices. Okay. So and I need to actually look up the matrices. And if you try to implement, you argue properly, why do you think that the time complexity is like this? Okay. So you have to argue. Remember one thing I must add here, that when you design an algorithm, two things must be done. One is you must prove that the algorithm is correct. What does the correction mean? It terminates. That is one thing. But what algorithm correct means, when it terminates, it does not produce a wrong result. If it produces a wrong result, then that algorithm is not useful. Okay, number one. Number two, what is the guarantee that it terminates? That means you have to show that after certain amount of steps, after certain number of steps, the algorithm will not proceed any further. It has to terminate. Like the pseudocode cannot run forever. I mean, there cannot be forever execution. Now, the termination proof comes from the pseudocode. If you follow the pseudocode, you have to argue from the pseudocode that it will terminate. Okay. If you do not, there are other techniques as well to prove this thing. You can derive some inductive property or something, so that you show that that property will not hold true up to after a certain point, and then thereby the algorithm will terminate. Okay. So that thing you have to look into it. And once the algorithm terminates, you get certain results, certain output. You have to argue that that output is worth, I mean, it's not useless. Okay? So that thing is very important. So, so these are two main things. So if you study this algorithm, Gale-Shapley's matching algorithm, you will understand that what kind of problem it is. I am in the process of forming the list of questions. For example, let me just read a few questions that we have set up, and still more we need to set up. So, for example, what is a greedy algorithm? That may be one question. Okay. Does the greedy technique always work? That is another question. It's a general question. You have to you try to answer. What is perfect matching in a bipartite graph? Define the stable matching problem in a bipartite graph. What is a blocking pair in stable matching problem? Write pseudocode of Gale-Shapley algorithm for stable matching problem. Is the Gale-Shapley algorithm for the stable matching problem is a greedy algorithm? Why or why not? What is the time complexity of Gale-Shapley algorithm? Explain the analysis. What are the data structure used in the implementation of Gale-Shapley algorithm? Then another interesting thing that another question is there, which is you need to do a little bit of if you understand Gale-Shapley matching, then you will understand this a little more. That the problem of I mean the Gale-Shapley creates a match where I mean it's not necessary that everybody gets its best preferred partner. It is not, right? Because I mean the teacher prefers one student, but that student may not prefer that teacher. Okay, so due to this asymmetry, every student may not get the best teacher. Every teacher may not get the best student. But apart from that, Gale-Shapley has certain properties. If you study, you answer all the questions, that you will understand that it also does not guarantee that, I mean, if I do not get the best teacher I like, I will get the second best. It also does not guarantee anything like that. Okay. So there may be another question that I have said is that you can search in the Google that what is rank maximal matching? Explain with an example. So this is a different kind of matching with different conditions. What is rank maximal matching? Name 5 applications of Gale-Shapley matching. Okay. So name different applications of Gale-Shapley matching. You need to actually draw small pictures in every question. Okay, at least for bipartite graph, etc. To exemplify, I mean, what it is. For example, name 5 applications of Gale-Shapley matching. You should not actually just say, okay, it is teacher-student assignment, it is marriage, it is I mean, hospital patient assignment or doctor patient assignment. If you just write that the example is not clear, the clarity comes when you say teacher-student assignment and say this is the situation. In a particular case, teacher will like to get a student for particular BTP or MTP or PhD. Similarly, student will also want to have a guide and they have their preference. And in this case, uh, I mean, if there is a possibility of blocking, the proper matching is not done. So this is a nice example. So you should this each example, this question, the name 5 applications of game supply matching. Each example you take, you should actually highlight a little bit about where it is important. Okay. Okay. So that's it for today. I will now expect some questions because I'm in the process of setting up questions, all possible questions for this particular problem. We need to write up the notes or reports answering all the questions. You can take the help of the book, you can take the help of Google, okay? But as I told you, every answer should be complete and nice so that overall understanding is crystal clear. Okay. So any questions up to this point? Yeah, there is one question. Will plagiarism be checked? Okay, this is a nice question. See, I can tell you that this everybody has to write this thing. Okay, if every copy, so suppose I'm telling you this way. Suppose there is 10 marks. Okay, this 10 is a representative. I mean, it's not the absolute thing. I mean, in that way, this course actually